In this video, you will learn about the principle of moments. The principle of moments states that the anti-clockwise moments around a pivot must be equal to the clockwise moments around the same pivot. This statement gives us a nice simple equation that we can use to calculate unknown forces and unknown distances around any equilibrium example. Take, for example, this problem from your booklet, which you can fill out along with me as you're watching the video. This problem shows a uniform beam with a 20 Newton weight on one side and an unknown weight on the other side. The 20 Newton weight is 12 meters from the pivot and the unknown weight is 8 meters from the pivot. The beam is horizontal, which means it is in an equilibrium position, which means it's balanced. The first thing to do in any of these problems is to write down the equation. The sum of the clockwise moments is equal to the sum of the anti-clockwise moments. That little zigzag letter, which is the Greek letter sigma, just means sum of, and it's a quicker way of writing it down. It's then worth labelling on your diagram which direction is clockwise and which direction is anti-clockwise so that you know which moments are going on which side of the equation. The next step is to annotate your diagram, labelling up the forces and the distances with simple ways of writing them down like F1, D1, F2, D2. Try to keep the numbers of the corresponding forces and distances the same. So you can see that F1 and D1 are a pair and F2 and D2 are a pair. And if there are more forces, this avoids confusion later on. Then we write out the equation in terms of the forces and distances using the annotation we've used above. So F1 times D1 equals F2 times D2. We will then substitute in the appropriate numbers in the place of those letters that we've written. So F1 doesn't have a number, so we'll keep it as F1. D1 is 8, so we'll write 8 meters there. You don't have to write the unit, but for the sake of this, I am to show you. And F2 is 20 newtons and D2 is 12 meters. Next, we'll simplify the problem so you can quickly see that 12 and 20 can be multiplied by each other to give 240, so pop that in your calculator. The left-hand side doesn't need to change but can be written as 8F1. We then need to isolate F1 by removing the 8 from it, and the only way to do that is to divide it by 8, and that will cancel out the 8, leaving 1 F1. And because it's an equation, we have to do the same on the right hand side, so we divide that side by 8 as well. So we end up with F1 equals 240 divided by 8. Finally, we solve the problem by smashing that into a calculator, which gives us 30 newtons. To make problems a little bit more challenging, they like to throw in some extra forces on either side of the pivot point to make the equation more complicated. If you follow the same setup, it's actually not any harder than it is before. There's just more steps involved. So you can see from this problem that you've got one force going anti-clockwise, or one force providing an anti-clockwise moment, and two forces providing a clockwise moment around the same pivot point. You should label these on your diagram. Next, we'll write out the same equation as we wrote out before. The sum of clockwise moments equals the sum of anti-clockwise moments. Remember that letter sigma is sum of. Label up the diagram in the same way. F1, D1, F2, D2, and F3, D3. Next step is to rewrite out the equation in terms of F's and D's. So we'll have F1 times D1 equals F2 times D2 on the clockwise moment side. And that will be equal to F3 times d3 on the anti-clockwise moments side. Substitute the numbers in the appropriate place as the arrows show. So 6 newtons times 0.7 meters plus 4 newtons times 0.2 meters is equal to F3, because we don't know it, times 0.3 meters. Simplify the problem by multiplying the things together that can be multiplied. So 6 times 0.7, 4 times 0.2, and F3 times 0.3. F3 needs to be on its own, so we need to divide the right hand side by 0.3 to cancel those out. And as always, because it's an equation, we need to divide the left hand side by 0.3, so we're being balanced. Excuse the pun. This means that 4.2 plus 0.8 all divided by 0.3 must equal F3. So we'll smash that into our calculators to get the answer, which comes out as 16.7 newtons.